1314 notes that we're going to cover properties. All right. Properties are something, there's going to be times where you guys are going to need to write some of these down. So if you need to pause the video to write down some notes to yourself on what properties are what and some examples of them, I absolutely suggest you do that. We cover these now and we use them all year. You use them next year in geometry. You use them the year after that in Algebra 2. These are things that you've seen before, but we really got to make sure that you know and you understand the meaning behind them. Okay. So let's take a look. We have the expressions 4k plus 8k and 12k are called equivalent expressions because they represent the same number. The properties below allow you to write an equivalent expression for a given expression. So here we have properties of equality. That's what these are called, okay? Properties of equality. The reflexive property is literally just when there's the same thing on the left side of the equation as there is on the right side of the equation, all right? So same exact thing on both sides is the reflexive property. Again, properties of equality, so we need an equal sign. Symmetric property is when it's the same thing just backwards. So if I were to write, x plus 2 equals 2 plus x, that is the symmetric property. Same thing, just in a different order. All right. Well, excuse me. Hold on. Let me word that a little bit better here. Sorry. If we have x plus 2 equals 4, and then over here I write 4 equals x plus 2. That's the symmetric property, okay? Same thing on both sides, just they mirror one another. The transitive property we use a lot in everyday, life, and we just don't even realize it, but that's if A equals B and B equals C, then A equals C. I think the most common thing for students here is that, like, if I owe Johnny $1 and Johnny owes Sally $1, then I'll just pay Sally the $1, okay? That's like the transitive property of borrowing money. And then the substitution property is just literally substituting something in for something else. So, for example, if n equals 11 and we have 4n, then that can equal 4 times 11. That's just the substitution property. We use that a lot for like simplifying things, and we'll see how that works in just a second. The sum of any number and 0 is equal to the number. So 0 is, when we add that, we call that the additive identity. So if we have any number and we add 0 to it, we get the number. That's the additive identity. Additive inverse is when we add a number and its opposite, and we actually get 0. So 3 plus negative 3 is 0. That's an example of the additive inverse. We also have properties that are associated with multiplication. Multiplicative identity, when we added, to keep the number, we added 0. When we multiply, we're going to multiply something by 1. That's the multiplicative identity. That's down here. The multiplicative property of 0 means that anything times 0 is 0. You guys know that stuff. The multiplicative inverse is that for every number, there's a number that we can multiply it by to equal 1. And that number is its reciprocal. You guys have heard that word before. The multiplicative inverse is when we use the reciprocal to multiply it together and get 1. Like right there, right here. Okay. So examples. We're going to evaluate an expression, and then, which we did in the last video, but now we're going to identify the property used in each step. And even on some of these, you can see right here, this is done for us. So let's take a look. I'll do 1A with you, and then you guys are going to pause and do 1B. So 1A. What allows us to... what you have to do is you have to find the difference. The difference from this line to this line is that instead of 4 times 2, we now have 8. What we've done is we've substituted 8 for 4 times 2. We know that that's the same thing, so that is substitution. Okay? And let's clean that up a little bit. That's prettier. So that's substitution. Okay? Down here, 8 minus 8 equals 0. That's the difference, is we've changed 8 minus 8 to now 0. That's the additive inverse. All right. Then the next thing we have is we have, instead of 2 times 3, we have 6 now. Well, that's substitution again. That's when we're substituting a value for an equivalent value. And then 6 plus 0, we know that equals 6 because of the additive identity. Because anything added to 0 is itself. Go ahead and pause the video. Try 1B on your own. See if you can get some answers there. Pause the video now. All right, check your answers against mine. For the first step, I got substitution. For the second step, I got additive inverse. For the third step, I got multiplicative inverse. Fourth step, multiplicative property of 0, and the last step is additive identity. If you didn't get those, put a star or a check mark or a heart or something next to that, and we'll take a look at that together in class. We also have the commutative and associative properties. You guys have been learning about these since elementary school. You might not have always used the terminology, but you've been doing these for a long, long time. Commutative property is really when we just change the order that we do things. That's the commutative property, okay? The associative property is when we change the order based on grouping, all right? So here we're doing A plus B first. Here we're doing B plus C first. This only works, well, first, they work for addition and multiplication. Both these properties are good for addition and multiplication. But they only work when it's all addition or all multiplication. You can't have a mix because then it becomes an order of operations issue. So let's take a look at a real world example down here. It doesn't matter what order we add these in, okay? We're going to get the same answer. So we rearrange them to make them simpler. Instead of adding 6 plus 7, 5 to that, we're going to add it to this right here because it adds nice and neat to 30. And then we can add this and to that, and that's 3450. It's a way of, commutative properties sometimes helps you do mental math by just grouping the things that we want grouped because it makes it easier to do in our head. So for example, here, 300, 30, 50, 25, 50, and 50. Well, it makes more sense to add 30 and 50 together and get 350. Okay, I'll add those first. Then add these second. That's 55, so 56. And now I can add those and get 406. Okay, so it's a way of helping you do faster mental math. Here, evaluate 5 times 7 times 4 times 2 using multiplicative properties. Name the property used. So here again, it makes more sense to rearrange the order so we do 5 times 2 first. The reason is because 5 times 2 is 10. That's easier. It's easier to work with when we have numbers like 10. Okay? Take a look at 3a. Probably easier to do these two first and get 29. Okay? And then 29 times 4, well, you can do 20 times 20 times 4, which is 80. 9 times 4, which is 36, and add those together and get 116. Okay? Helps you do mental math when you change the order. For example, 3b. You take a look at 3b. We can add, we can multiply 5/3 times 3 and get 5. 25 times 2 and get 50, and so that's 250. So it's just a faster way of doing it. We can do it in our head. We move them around using commutative and associative properties and then substitution. The properties aren't as important here, really. What I want you to understand is that this is a mental math time saver. Okay? All we're doing is using these properties on both of them each time. Okay? Change the order, group them, and then substitute. We will come back to that in a bit. Let's take a look here. 1-4, the distributive property. All right, you guys have been working with this before. You have some familiarity. The distributive property allows us to multiply a number outside a group of parentheses to the numbers inside the group of parentheses. It also allows us to go in the opposite direction. We can have that number there first. We can use this all sorts of different ways. The symmetric property allows us to use this as the distributive or that as the distributive property. Okay? Let's take a look at an example. A group of 7 adults and 6 children are going to the University of South Florida baseball game. We use the distributive property to figure out how much the tickets cost. Okay, so tickets are $2 each. We have 2 times the quantity 7 plus 6. We know that's 2 times 7, 2 times 6, that's 14 plus 12. I can check that because I know that 7 plus 6 is 13, and 2 times 13 is 26. That's how I know the distributive property works. All right. So if we have 3 adults, an 11-year-old, and 2 children under 10 going to a baseball game, write an expression to determine the value or the cost of the tickets for the group. So we have 2 times 3 plus 1 plus 2. Okay? Practicing with the distributive property, we would do 2 times 3 is 6, 2 times 1 is 2, and 2 times 2 is 4, and we would get 12. You also know that 3 plus 1 is 4, and 4 plus 2 is 6, and 2 times 6 is 12. So that's how much. Let's take a look here. We can rewrite things using the distributive property, and it can help it not rewrite because we're doing these in our head. And it's kind of what I alluded to earlier. 7 times 49. If I wanted to do 7 times 49 in my head, it might be easier just to do 7 times 50. Okay, and then do 7 times 1 and subtract 7 from 350, and that's how you get 343. Go ahead and try these. See if you can get answers to 2A, B, C, and D without writing anything down and without your calculator, okay? See if you can get answers there without writing anything down and without your calculator. Go ahead and pause the video and get some answers. Okay, you've unpaused. Let's see if your answers match mine. For this, I did 300 times 15, and then 4 times 15, and I got 4560, okay? For 2b, I did 44 times 2, got 88. 44 times a half, got 22, and I get 110. For this one, 200 times 5 and 10 times 5 gives me 1050. And for this one, 50 times 17 and 2 times 17, and that gives me 884. All right, easy stuff here. If you're not sure on those, remind me in class, and I'll explain the mental math a little bit further. We can also rewrite algebraic expressions with the distributive property, and we've done some of this already with simplifying things. Let's go ahead and take a look down here. Pause the video. See if you can get the same answers that I get. Try 3A, B, C, and D. Go ahead and pause the video now. All right, you've unpaused. Let's take a look. This is 16 plus 8n. This is, when we distribute here, there's 3 terms, and sign becomes an issue, but let's take a look. That's negative 6r, negative 18g, and positive 6t, because the negative times the negative is a positive. Down here we have negative 6 plus 15q. And here we have 32 plus 12m. All right. Sometimes when we distribute, we're going to end up with like terms, so I'm going to be able to simplify. These are 3 different terms that aren't like. To be like, they have to have the same exact value, or the same exact variable, and the same exact exponent. Here, that and that, those are like terms. Same variable, same exponent. So, to combine like terms, we're going to find the ones that have the exact same variables, the exact same exponents, and then add. So down here, those 2, we can combine those 2. We can use the distributive property to show that this is true, but when we do the problem, we're not really going to use the distributive property. So go ahead and pause the video here, see if you get the same answer I got. Notice that it says, if it's not possible to simplify it, just write simplified. Go ahead and pause the video now and try these problems. All right, you've unpaused. Hopefully for 4a, you got 2n. 4b, that is as simple as it gets. For 4c, you got 4y cubed minus 6y plus 5. And for 4d, you got negative 6a squared plus 5a plus 4. Your order might be different than mine. We can talk more about what standard form is, but basically I'm going to go greatest to least with the exponents, okay? Greatest to least. Is yours right if you have negative 6y plus 4y cubed plus 5? Yes, it is correct, but it's not the best way. So we want to practice. This is preferred over that. All right? One more example here with to write and simplify expressions. Oops, sorry, too fast, too far there. So use the expression twice the difference of 3x and y increased by 5 times the sum of 2x and y, and then we're going to simplify that expression. So we have to take from the words, write it out like they've done here, and then we're going to work our way down and get the simplest term possible. Okay, it's in simplest terms possible. So let's take a look. Write an algebraic expression for this verbal expression. Go ahead and take a second to do that. Hopefully you got, or are on your way. If you're still working, go ahead and pause it for a second. 5, okay, times the difference, and this is where we have q squared minus r in parentheses, plus 8, and this is going to go off the screen, but I'll move it in just a second, 3q plus 2r. All right, so here's the expression I got, right there. Now, simplify that. And as you go, see if you can justify which properties to use. Go ahead and pause the video, try that problem, and then I will work the problem with you. Okay, so the first thing we did is I got 5, yikes, that's not a 5, 5q squared minus 5r, and that's the distributive property, plus distributive property for both of them, 24q plus 16r. Okay, so step one was that, and that's the distributive property. Next is I'm going to use the commutative property to rearrange some things. So 5q squared minus, let's go plus 24q minus 5r plus 16r. I just put the r's next to each other so I can see it a little bit better. And then I'm going to substitute 11r. Instead of writing negative 5r plus 16r, I can substitute that with 11r, and that's as simple as she gets. Okay. Here's a nice little concept summary of the things that we've done, properties of numbers, the ones you need to know. Oh, sorry, skip this. The coefficient, that's the term out front. You guys have heard that word before, but the coefficient is the term in front of a variable. All right. Nice little concept summary of the properties we've looked at. That's it for the notes. I'll see you in class, and we'll make sure everybody knows what they're doing, okay? Have a good weekend. See you on Tuesday.